Next class we're going to look at is the Autonomous Commands Factory. When we looked at the robot container class earlier, I had mentioned that that class can get really long, and so we've taken some steps to move some functionality into other classes. The Autonomous Commands Factory is an example of that. So inside of the constructor for robot container, there's a section here where we register the autonomous commands based on whether we have a differential or swerve type drivetrain. And so we'll dive into the Autonomous Commands Factory class now to look at that. You can see with how it's invoked here, it is a singleton object. So here's Autonomous Command Factory. And like I said, it's a singleton. Um, we use AdvantageKit's log dashboard chooser here to select our autonomous routine. That way that it's logged which routine was selected. So we have that here. Here's our get instance method, which will return a reference to the singleton. It lazily constructs it when needed. Um, the get autonomous command is called inside of the robot class to retrieve the autonomous command inside of AutoInit. But what we're interested here is the configure autos commands method, which is called from robot container. It takes as parameters the drivetrain, a reference to the drivetrain, swerve drivetrain, and the vision drivetrain for this configure autos command method. There's another one down here that is overloaded and takes a reference to a differential drivetrain and a vision object for differential drivetrains. So there's two different configure auto commands methods based on the type of drivetrain that's involved. We had a do nothing command as the default option in the auto chooser, so that if nothing is selected inside of Elastic Dashboard, the robot doesn't do anything unexpected. And then you can see a couple other things. So I'll talk through a couple of these. Much of this is used in testing, and then you'll see where, or tuning, but you'll see where you can put like competition autos as well. We don't use this that much anymore. This is an auto command that basically allows you to set the robot in a known location on the field. You run this auto and it updates the odometry so that the robot is at that point. These days, it's much more common for us to just set the robot on the field and reset the pose to the vision pose estimate. Um, and we'll look at vision more later, and I think we might have seen that command already anyway. But we still keep this around. I suppose maybe if there were no April tags on the field yet and we're doing other things, this would still be a useful auto to have. So basically each auto is similar. We build the command. This one just does a reset pose by reading the start point path that we have created in Path Planner, catches the exception and whatnot, and then adds it to the auto chooser with the name start point. So the next couple here is the distance test. It says used for empirically determining the wheel radius. I think we use this more generally. We have a better way of doing that, which we'll get to later with our characterization commands. But this is still helpful driving at 3 different speeds. And making sure checking like the accuracy of the distance. And so this uses a helper method called create tuning autopath, which we'll look at in a moment, that encompasses much of the logic. So we can have a distance test slow, medium, and fast, and different auto names for those, which refer to path planner paths. But this does some more stuff for tuning, which we'll see in a moment. Similarly, we have a section here for helping us tune auto. So we have a rotation test slow and a rotation test fast, oval test slow, oval test fast. All of these are useful for tuning our PID that we pass to Path Planner. I suppose I should actually show you what these look like. That would be helpful. So here's some of the paths. So you can see like we'll open up distance test medium. All it does is just drive in a straight line. Um, for probably like 2 meters, 4 meters. Um, and so we can see how close we get to that target distance. Um, Oval test. So we have a couple different versions of those, but you can see there it's half of an oval and comes to a stop and does a rotation as it goes. Here's the other half coming back. Um, Here we have specific max velocities that make this one the fast one versus the slow one. We have a rotation test as well, where it goes in a straight line as it rotates. Um, so that can help us tune our auto PID as well. And the start point one, it moves, but it never does. It just reads the start point and it knows we've started at this location, which is x equals 1, y equals 1 in terms of a known location. So these are the paths we use um, for tuning auto. So we'll look at the create auto tuning path here in a moment, but we have ones for rotation test slow and fast, oval test slow and fast. This helps us tuning um, the PID, drive velocity tuning. This helps us tune just the drive velocity PID controller that we use, and let's dive into that command while we're here, and we'll come back to it. What this does is it drives forwards and backwards at a variety of velocities. And it pauses between each one for a brief period of time. So you can see here driving forward at 2 meters per second, backwards at 0.5, forward at 1, forward at 3, forward at 1, backwards at 1, backwards at 3, backwards at 1. And then we capture all of this with Advantage Kit. We look at it in Advantage Scope, and we can see if we need to adjust our PID constants so that it follows the commanded velocity well. So that's the drive velocity tuning command. We have a similar one for swerve rotation turning command. You can see here that it's driving very slowly. It probably won't even move 0.1 meters per second. But you can see that um, that the X and the Y velocities will cause it to point in different directions, like different 45-degree angles. And again, we can log this with Advantage Kit, look at it in Advantage Scope, and see the response to commanding different turn angles, swerve angles, and look at that as well. So here's how we actually determine the drive wheel radius. We have this get drive wheel characterization command. This uses a different class, the characterization commands class, wheel radius characterization. This class is written by Mechanical Advantage. It's included in our project over here, but we use that to actually check the wheel radius. It's been the most accurate approach that we've seen. Here is the configure auto commands for if we have a differential drivetrain. We have the start point one. And then there's an example path planner here for use with the XRP that does a differential example as well, which is helpful. So let's jump down to here. Create tuning auto path was the helper method we saw referenced in several places. Basically what it does is it tells the drivetrain that we want to capture the initial conditions, and we'll look at the drivetrain class later, but we'll jump to this method right now. What this does is it stores in an instance variable of the drivetrain class what the initial distance is as read from each of the 4 swerve modules. So we know initially each swerve module thought it was here, and that allows us the opportunity that after we run the path planner auto that is named, we then capture the final conditions, which we'll jump to that method as well. And here it looks at it and calculates the difference between where the robot ended up in terms of the current pose estimate and where it should have ended up based on the path planner path. And it logs the difference between those two. Then if it was told to measure the distance, it will also go through each of the 4 swerve modules, figure out how far they went, calculate the average of the 4, and log the auto distance as well. So that is helpful. I guess I'm sorry, it's finding the difference between where the module started and where it ended, the absolute value of up, and then finding the average difference in distance. I misspoke there. Um, and so that helps us tune our autos as well. So you can see how that's working. And so that's what the create auto tuning path does, is just a nice way to do those before, capture the initial conditions and do some additional logging at the end so we can check on all those different autos. So that is the autonomous command factory. Um, that all of this code is now in its own class and outside of robot container, which helps keeps things a little bit cleaner.